So the reason that you did calculator work on inverse trig last night is so that you can use it in a real life situation. An important thing to remember, and I will mark off for this, is that when you do inverse trig, there's a unit of a degree on there. Just like I mark off for units of feet and miles and meters and whatever, the unit of a degree is just as important and valid. So every inverse trig answer is going to be in degrees, and so your calculator needs to be in degree mode. Okay, just a little circle, right? Or you can write the word, I suppose. You could write the word degrees if you wanted, or you can use the little symbol. All right, so let's see how we would use this inverse trig to solve a real problem. All right. My friend Snoo is trapped in a burning building and awaiting rescue. Yes. Or she's going to run into a burning building on purpose just to get rescued. All right. So the fire department arrives to save her. Okay. So and they have a 120-foot ladder. All right, she goes to a window. (105 feet off the ground). So what angle should the firefighters set their ladder at so that they can reach her? Yeah, so in the middle of this, the firefighters will stop, do their trigonometry, and then set.
I just imagine a firefighter like this.
Did I get that?
The guy in the iron truck just ready, hand on calculator, and got you.
They don't have calculators, but they have computers in their little they would enter in the height of the building, and then they would know what to do. Everything happens very fast. That's why they train and practice. All right, so here is our building. Here's Snoo leaning out of the building.
Wait, she's leaning like...
out the window. Like, help. All right, so she is 105 feet off the ground, and the firefighters come with their 120-foot ladder. And we need to figure out the angle that they will use to come to her rescue. All right, so once you've read the question and turned it into the drawing of a right triangle, so every question should be able to be turned into a right triangle, then it's your job to decide what trig to use. Okay, so if you look at this, what do you think? Based on where the numbers ended up, this is going to be sine, because 105 is opposite of the angle we want, and 120 is the hypotenuse of the triangle formed. And so this is going to be sine of the angle theta, which I don't know, is going to be the opposite, 105, over the hypotenuse, 120. And then it really only takes one thing to do on both sides to solve for your angle. So how do I get that angle alone? What do I want to get rid of? I want to get rid of sine. How do I get rid of sine? Not divide.
Arc sine.
I want arc sine. Okay, so I do arc sine on both sides. And so that gets me the angle alone, and I have the arc sign on the other side. And so use your calculator now to determine the measure of the degrees that the angle will be, that the ladder will be leaning up against the ground. Okay, does anybody have that one? Say it again. 61 point. Yep. Okay, 045, and then what are the units on this answer? Not feet, degrees. This is an angle, and so this is going to be measured in degrees.
Definitely?
Yes, ma'am.
Alright, I think we need to work on it. It was only the first example.
Okay. All right.
Yeah, that's the whole thing so much harder. I know. This is the first time. Oh. Yikes.
All right. All right, a person riding a roller coaster at 980 feet above the ground. Okay, so maybe they are getting to the top of like the extreme scream or whatever, you know, you're at the top, right? Or what's that one in Knott's Berry Farm that like is the tower thing with the circle thing that you go all the way?
Oh, Sidewinder?
Oh, it's gone? Oh.
Because people kept getting stuck at the top.
All right. The one at Magic Mountain. No, they have it at Knott's Berry Farm too. I just forget the name. Like you're in and then they like drop you and then raise you. Or you could be in like Tower of Terror, I guess, at California Adventure. Whatever. Okay, we're 980 feet in the air. Okay. And so this person is up there. Okay, and they see a friend below 450 feet away from the base. Say, hey, I see you. Okay. All right, what angle of depression are they looking down at? Well, we know the angle of depression is always the same as what other angle? Right, so the person who's on the ground looking up at the other person, they're looking up at the same angle of elevation that the person at the top is looking down. So it's the same either way, which, I mean, the people are looking at each other. All right, so we got to turn this into a right triangle. We don't have to draw the roller coaster. We just have to know that the person who's on the top is 980 feet high. And they see a person below, and from the base, that is 450. Okay, so sometimes people draw their triangle incorrectly, and they might put 450 like that, and they're like, oh, but I'm seeing the person 450 away. Okay, well, we're not talking 450 through the air. We're talking 450 along the base, which is the bottom. Another thing is you can't have a hypotenuse that's smaller than the side you're at. So that's impossible to have a 450 as your hypotenuse. So those are two reasons why you would not put 450 as your hypotenuse. And so we want to know the angle of depression, which they're looking down on. And the angle of depression, which is on the outside. Remember, angles of depression are always on the outside of the angle, out here. But they are the same as the angle on the inside. So it's up to you which one you find. You can find both, or either, but they are going to be the same. Angle of depression on the outside and on the inside. All right, so based on the 980 and the 450, what's the best trig for this? Okay, for sure. We're going to use tangent because, and we'll use the symbol for theta, because tangent is opposite over adjacent. So what goes on top? 980 is the opposite. 450 is the adjacent. And so now I want to get this theta angle alone. And so what will I do to both sides here to get it by itself? All right, so theta is going to be the arctan, or the tan inverse. And then we go back to our calculators and we evaluate that. If you ever get an error, it means you put the sides in the wrong place. So that's another, it's like another place for you to go, oh, wait a minute, what did I do wrong? Okay, so because if you tried to do one of these where you had the hypotenuse in the wrong place, then you get the wrong answer. All right, what do we have for this angle of either elevation for the person looking up or depression for the person looking down? What does that turn out to be? 65.336 units? Degrees.
Are all of these going to be degrees?
Yes, ma'am. Anything where you use arc or inverse is always going to be degrees is your answer. Okay. All right. Suppose you go into architecture, maybe landscape architecture, and you're designing a swimming pool for a client. Okay. There is. Landscape architects, they make bank. All right. A client wants a pool. Uh, 60 feet long. Because they want to do laps or whatever.
That's what you go to the water.
5 feet wide.
Okay. With a 4-foot shallow end. Because they got little kids. And, hey, the client always gets what they want. Okay, and an 11-foot deep end. What should the angle of the bottom of the pool be? All right, so we need to come up with, turn this into some other, make this pool into some kind of a triangle. All right, we've got the water on the top of the pool. We know that that's going to be 60. We know that the shallow end of the pool is supposed to be 4. And the deeper end of the pool is supposed to be 11. All right, so then I need to connect these to make my hypotenuse. But where is my triangle?
But what if you don't have to use the track 11?
Okay, so to get my triangle, I need to make an imaginary line that's going to go straight across here. How long will that yellow line be? Still 60, okay. But what about the side where it's not 11 anymore, is it? Okay, because I've now sort of like chopped off part of it.
7.
So it is going to be 7. So 11 would have been the whole thing, and 4 would have been the shallow end. But I'm only using 7 now. And I want to know what the angle of the slope of the pool should be. So my angle is up in that corner so that I know how to slope this thing. Okay, and so then just again, you're going to choose your trig from the picture. The hardest part, half of your homework questions have the picture already drawn. The harder ones are going to be where you got to come up with the picture yourself. All right, so we've got tangent again is the choice, because 7 is the side that's opposite, and 60 is the side that is adjacent. And so we'll use the inverse, or the arc of tan again, to get 7 over 60. And then determine what the degrees are. That would be the slope of the pool, or the bottom of the pool. Then you can get out your little digger and start creating this pool for the client. Probably a little bobcat or something. All right, who's got the angle? Yes, I got 6.654. That's in degrees again. Okay, I got one more example and then we're done. And then you can have the rest of the time to work on your homework. And I hope you work. All right, last one. An offshore oil rig needs to get its workers back to the dock. Okay. The ferry, or the ferry that's going to do that, the ferry charts the course between the dock and the oil rig. It's got to go back and forth and bring those workers 2 miles west and half a mile south. What bearing should the boat use? All right, so we know that the ferry has to sail southwest because we know that it's going west and it's going south. So that's southwest together, or all together. What quadrant is southwest in? Okay, can you picture your compass?
3.
Quadrant 3. Okay, so we need to, because we know it's southwest, we need to draw our triangle in quadrant 3. And we know that it's 2 miles on the west part and a half a mile on the south part. Now I didn't draw this completely accurately, but that'll be 2 because that's on the west side, and that'll be half because that's on the south part. Where do I put the theta? Where do we always put the theta? Where will it be? By the origin. So theta is going to be here. Okay, so we're going to set this up. What's the best trig? Tangent again. Okay, so let's set up tangent. So tangent of theta is the opposite, which was half, over the adjacent, which was 2. So theta itself would be the inverse tangent of half over 2. So let's figure out what that is going to be. So inverse tangent, and you type in 0.5 or half divided by 2, and you're going to get a tangent of 14.036 degrees. However, that is not the value of the bearing. When you answer, you don't stop here. That is the answer for theta. Okay, so let's add this here. This turned out to be 14.036 degrees. But bearing has to count all the degrees that came before that. Bearing always starts at your north line and it counts all the degrees in all the quadrants leading up to that angle. So it has to count the 90 degrees in quadrant 1. It has to count 90 more degrees in quadrant 2. And how many more degrees does it have to count in quadrant 3 before we actually get to the theta angle? 75 point, say it again, 964. And it has to count all of those as well. So bearing the actual answer is going to take the 90 and add it to another 90 and add it to the 75, 964. That will be the answer to the question. So we didn't just stop with theta, but we had to give that's the answer for theta, but it's the answer for bearing is going to be 90 plus 90 plus 75, 964. Which altogether is a bearing of 255.964 degrees. So that's the only little wrinkle, is when you answer a bearing question, you can't just stop with theta. You got to add up all the degrees that lead up to that.